The Global Maritime Distress and Safety System, or GMDSS, is an internationally agreed-upon set of safety procedures and communication protocols. It uses a suite of sophisticated technologies to ensure the safety of life at sea. Implemented by the International Maritime Organization, GMDSS aims to make it possible to rapidly alert rescue authorities in the event of an emergency. It ensures that assistance can be dispatched promptly to those in need, regardless of location or time of day. Before GMDSS, maritime distress relied heavily on Morse code transmissions. These were often unreliable, especially in remote areas with limited radio coverage. GMDSS revolutionized maritime safety by using automated systems and satellite technology. It provided a much more reliable and efficient means of communication during emergencies. The system is designed to be comprehensive, covering a wide array of potential maritime emergencies. These range from mechanical failures and collisions to medical emergencies and piracy incidents. By standardizing distress signals and communication protocols, GMDSS enables a swift and coordinated response from maritime rescue agencies worldwide.
The primary objective of GMDSS is to enhance maritime safety and make it easier to rescue people in distress at sea. It does this by achieving several key goals. Firstly, GMDSS ensures that distress alerts are received quickly and efficiently by search and rescue authorities. The system utilizes a combination of satellite and terrestrial-based communication systems to guarantee near-instantaneous transmission of distress signals. Secondly, GMDSS aims to improve the coordination of rescue efforts. By providing a standardized communication framework, GMDSS enables different rescue centers and maritime agencies to share information and coordinate their response effectively. This seamless exchange of information is crucial in ensuring that rescue efforts are fast and well coordinated.
Lastly, GMDSS aims to prevent accidents by providing maritime safety information to seafarers. This information, which includes weather forecasts, navigational warnings, and maritime safety information, helps mariners make informed decisions and avoid potential hazards.
The GMDSS is a comprehensive system that relies on various equipment to ensure maritime safety. The specific equipment required on a vessel depends on its area of operation. However, some of the most essential GMDSS equipment include EPIRB, Emergency Position Indicating Radio Beacon. A vital piece of equipment, the EPIRB transmits a coded distress signal via satellite to the nearest rescue coordination center. This alert initiates the search and rescue operation. EPIRBs are designed to activate automatically upon contact with water, ensuring that a distress signal is sent even if the crew cannot manually activate it. SART, Search and Rescue Transponder. This device is activated in an emergency and transmits a signal that can be detected by radar systems on other ships and aircraft involved in the search and rescue operation. When a SART receives a radar signal, it responds with a series of dots on the radar screen, providing a visual indication of its location and making it easier for rescuers to locate the distressed vessel. NavTex, Navigational Text Messages. A receiver on board receives navigational and meteorological warnings and urgent information broadcast by coastal stations. NavTex ensures that vessels are constantly updated with crucial safety information, such as changes in weather conditions or navigational hazards. Inmarsat System, International Maritime Satellite Organization. It provides satellite communication for distress alerting, search and rescue coordination, and general communication at sea. It enables vessels to communicate with shore-based stations, other vessels, and rescue coordination centers, even from remote locations. VHF/MF/HF radios. These radios operate on different frequency bands and are used for distress alerting and communication with other vessels and coastal stations. VHF radios are for short-range communication, MF radios are for medium-range communication, and HF radios are for long-range communication.
The GMDSS establishes a structured framework for communication in distress situations. It categorizes communication functions based on the area of operation of the vessel. These are Sea Area A1. This area is within range of VHF coastal radio stations. It offers the most comprehensive coverage and relies on continuous VHF radio coverage for distress alerting. Sea Area A2. This area extends beyond Sea Area A1 but remains within range of MF coastal radio stations. It relies on MF radio communication for distress alerting and safety information. from Sea Area A3. This area covers most of the world's oceans beyond the reach of coastal radio stations. It relies primarily on satellite communication, specifically Inmarsat, for distress alerting and communication. Sea Area A4. This area encompasses the polar regions where satellite coverage may be limited. It may require additional equipment, such as high-frequency radio, for reliable communication. In the event of a distress situation, a vessel will transmit a distress alert using the appropriate GMDSS equipment for its sea area. This alert is received by rescue coordination centers and nearby vessels equipped with GMDSS equipment, initiating the search and rescue process.
Maintaining the GMDSS equipment in optimal working order is crucial to ensuring its effectiveness in an emergency.
Regular maintenance and inspections are essential to guarantee that all components are functioning correctly and are ready to be deployed at a moment's notice.
This includes checking battery expiry dates, inspecting antennas for damage, and verifying the functionality of all communication equipment.
There are two primary options for GMDSS equipment maintenance.
Ships can opt to have their crew handle routine maintenance tasks. This approach requires that crew members receive proper training and certification in GMDSS equipment maintenance. It is a cost-effective option, but necessitates a significant time commitment from the crew.
Many ports have companies specializing in maritime electronics. These companies offer comprehensive GMDSS equipment maintenance and repair services. This option relieves the ship's crew of maintenance responsibilities, but comes with additional costs.
Choosing the right maintenance option depends on various factors, including the vessel's size, type, area of operation, and the crew's expertise. Regardless of the chosen method, regular maintenance is vital to ensure the GMDSS equipment's reliability and readiness for emergencies.
Operating GMDSS equipment requires specific knowledge and skills. The International Convention on Standards of Training, Certification, and Watchkeeping for Seafarers, or STCW, sets the minimum requirements for GMDSS operator qualifications.
The most common GMDSS certification is the General Operator's Certificate, or GOC. This internationally recognized certification demonstrates an individual's competence in operating GMDSS equipment and understanding the relevant procedures for distress and safety communication.
To obtain a GOC, individuals must complete an approved training course and pass an exam. The training covers theoretical knowledge and practical skills related to GMDSS equipment, communication procedures, and distress protocols.
The exam assesses the individual's understanding of the GMDSS system and their ability to apply their knowledge in a simulated emergency.
Having qualified and certified GMDSS operators on board is not just a regulatory requirement. It is essential for the safety of the vessel and its crew. A skilled GMDSS operator can make a significant difference in an emergency, ensuring that distress signals are sent and received promptly, and that communication with rescue authorities is clear and effective.
The implementation of GMDSS has significantly improved maritime safety and has led to a substantial decrease in maritime casualties. These benefits stem from enhanced distress alerting, improved coordination, increased situational awareness, and global coverage.
GMDSS ensures a faster and more reliable distress alerting system compared to traditional methods. The use of satellite technology allows for near instantaneous transmission of distress signals, even from the most remote locations, significantly increasing the chances of a successful rescue.
GMDSS promotes better coordination between various search and rescue authorities worldwide. By establishing a standardized communication framework, GMDSS enables different agencies to share information and coordinate their efforts seamlessly, leading to a more efficient and effective response to distress situations.
GMDSS provides continuous access to navigational and meteorological information, enhancing situational awareness for seafarers. This information allows for better decision-making and route planning, helping to avoid potential hazards and reduce the likelihood of accidents at sea.
Unlike previous systems, GMDSS provides near global coverage, ensuring that vessels can call for help regardless of their location. This comprehensive coverage is particularly crucial for vessels operating in remote areas, where traditional communication methods may be unreliable or unavailable. GMDSS technology is constantly evolving to improve maritime safety further. Some of the most recent developments include in navigation, advancements in satellite communications, digital distress systems, and integration with other onboard systems.
The International Maritime Organization, or IMO, is developing e-navigation. This concept aims to integrate various maritime services and systems, including GMDSS, into a single user-friendly platform. E-navigation is expected to enhance safety by providing seafarers with more comprehensive and easily accessible information.
Advancements in satellite technology have led to the development of new satellite constellations, such as Iridium Next and Inmarsat's Global X-band. These constellations offer faster data speeds, lower latency, and wider coverage, further improving GMDSS communication capabilities.
Digital distress alerts are gradually replacing traditional analog systems. Digital systems offer several advantages, including increased accuracy, reduced false alerts, and the ability to transmit additional information, such as GPS coordinates and vessel identification.
GMDSS is increasingly being integrated with other onboard systems, such as automatic identification systems, or AIS, and vessel monitoring systems, or VMS. This integration allows for more efficient monitoring of vessels and faster response times in emergencies.
The Global Maritime Distress and Safety System, or GMDSS, has revolutionized maritime safety by providing a reliable and efficient means of communication during emergencies. As technology continues to evolve, GMDSS will likely incorporate new advancements and become even more effective in preventing accidents and saving lives at sea.
However, it's important to remember that technology is just one part of the equation. Seafarers must be well trained in using GMDSS equipment and procedures. They must also adhere to safe navigation practices to ensure the highest levels of maritime safety.
Regular training, equipment maintenance, and a commitment to safety culture are paramount in ensuring that GMDSS continues to protect those who sail the world's oceans.